Well, welcome back. In this lesson, we are going to work on solving some word problems, and our title of this lesson is Modeling with Functions. So most of this lesson is just going to be working through some word problems and showing you some examples of how to solve different types of word problems. The skills that you need to be able to have at the end of this lesson: you should be able to write algebraic expressions from word problems, and then just writing and solving equations that model different situations. So let's start off with a function, forming a function from a formula. And our directions say write the formula for the area of a circle as a function of its radius, diameter, and circumference. So let's start off with writing the formula as a function of its radius, and that one's pretty much just citing the formula where the area is pi times r squared. So this is a formula for the area in terms of the radius. Then to write a formula for the area in terms of the diameter, we need a formula for the relationship between the diameter and the radius. And since the diameter is twice the radius, we can substitute in, once we solve that for r is half of d, or d over 2. And then we can plug that back into the formula we had in part A. And that gives us a equals pi times d over 2, the quantity squared. And we can simplify that a little bit and write that as pi over 4 d squared. The circumference, then, we know circumference is 2 pi r. So if we want to write a formula in terms of the area as a function of circumference, let's go ahead and solve this for r, our circumference formula. And when we do that, we get the circumference divided by 2 pi is equal to the radius. And then again, we're going to substitute that back in here into the area formula for r. So we will get area equals pi times r squared. Substituting back in, we get pi times c over 2 pi, the quantity squared. And then simplifying that, we get pi c squared over 4 pi squared, which simplifies, hopefully I simplified that one more step. One of the pi's will cancel, and we'll get c squared over 4 pi. Here's a problem. I think we had this actual problem or something similar to it in one of our earlier lessons. It's a maximum value problem. Suppose we want to make a box that doesn't have a top to it from a piece of cardboard, and our cardboard's 8 by 15 inches, and we're just going to cut out squares from each corner, and the length of each square is x. Write the volume of the box as a function of x. Well, the formula for the volume of the box is length times width times height. Whoops. And so that one gives us, if we substitute in x times 15 minus 2x and 8 minus 2x, the product of those three things, and each of those sides, so the total length was 8, but we're subtracting off 2x squares. And then same thing with the other dimension. It was 15, but we're subtracting off an x from each end. So that's where that formula comes from. To find the domain as a function of x, we need to think about what values can x equal. Well, x must be bigger than 0. It needs to be a positive number, so x must be greater than 0. And each of these terms must also be greater than or equal to 0. So we can start by saying they're greater than or equal to 0 and then solving them. So this one gives us x has to be less than or equal to 7.5, and the one on the right, x is less than or equal to 4. So if we put those two together, we need to have x has to be, the domain of our function then is between 0 and 4. Part C says graph v as a function of x over the domain that we found here on your calculator and determine the maximum volume of the box. Well, if we actually plug that equation into your calculator, you will get a parabola, and then you can calculate using the second calculate function, calculate the maximum. The maximum volume occurs right up here, and that is 90.7 cubic inches. That's the y value. And then part D said how big should the cutout squares be to produce the box of maximum volume, and that is just the x value. And that x value is 1.6 repeating, which is the same as 5/3. This problem says the diameter of a right circular cylinder equals half its height. Write the volume of the cylinder as a function of its height. And they give us the volume for the cylinder. So first of all, if we have the volume of the cylinder was given to us. We have a couple of formulas that we're going to use. So it says the diameter equals half its height. So I went ahead and wrote a formula for the diameter is half the height. And we've got the volume. We also know the relationship between the diameter and the radius. There are 2 radii in a diameter. So those are the formulas that we will be using to solve this problem. So our goal is to write the volume as a function of height. So right now we have it as a function of radius and height. So we need to get rid of that radius. So the first step we're going to do is we're going to say the 2 radius is, double the radius, and that gives us half the height. So by using formulas 2 and 3 here, both of these are equal to d, so we can substitute in 2r right here into equation 2, and that's how I got that formula. So then what we need to do is just take a half of that and solve it. So if we divide both sides by 1/2 or multiply by half, we would get r is equal to 1/4 h. And now that we have a formula for r, we can plug that back in here to get rid of the r, and that will give us our volume in terms of height. And so substituting that back into our equation, we get volume equals pi times 1/4 h, the quantity squared, times h. And then when we expand what's in the parentheses, we get pi times 1/16 h squared times h. And then just simplifying that a little bit, we get pi over 16 times h cubed. And that now is our formula in terms of height. So that should be a V equals that. In the next 4 problems, we're going to write an equation to model the situation, and we need to define all of our variables. So that's something that I'm going to be watching for. Make sure that you're defining your variables when you're solving word problems. And then go ahead and solve the equation and make sure you're answering the question that was posed. If there's more than one question, answer all of them. So this first one says one positive number is twice another positive number. The sum of the 2 numbers is 390. Find the 2 numbers. So we can go ahead and write 2 equations, and I'm going to let x be one number and y be the other number. So I've defined my variables. And it says one number is twice the other. So I just said x is 2y. Remember, the word is means equals. One number is twice the other. And the sum of the 2 numbers, that means add, and we get 390. Well, now we can substitute x is 2y, so we can just replace this x right here with 2y. And we get 2y plus y equals 390. And then combining our like terms, we end up with y equals 130. Well, it says find the 2 numbers. I found one of the numbers, so I need to substitute that back in right here to get the second number. So I'll get x plus 130 equals 390, and x is 260. Second problem, Stan received a 3.5% pay decrease. His salary after the decrease was given. What was his salary before the decrease? Well, let's define our variables. M is the amount of money that Stan earned before his pay cut. And we are looking for what was his salary before the decrease. So we're looking for that value M. And he had a 3.5% decrease. So what is that as a percentage? 100% is what he was earning, and he got 3.5% decrease. So we're going to subtract that to give us 96.5%. And then as a decimal, that's 0.965. So if we take 0.965 times his salary, that ends up being 27,985. Solving for M, we get 29,000. Problem number 3 says Stacy invests $25,000. Part of it at 5.5%, part of it at 8.3%. How much is invested at each rate if she receives a 1-year interest payment of $1,571? Let's go ahead and define our variables. We're going to let X be the amount of money that she invested at 5.5%, and we'll let Y be the amount she invested at 8.3%. And then we should be able to go ahead and write 2 equations and 2 unknowns. We know the total amount she invested was $25,000, and I don't remember which, if I went down or to the right. Here we go. So X plus Y is 25,000, and then we can also write an amount that deals with the amount of interest. So if we take 0.055 times the amount she invested at that rate and add that to 0.083 times the amount she invested at the other rate, That should give us the $1,571 interest payment. So this second equation is in terms of interest. The first equation is in terms of principal. Solving the first equation for x, we get x equals that, and then we can substitute that back into the second equation after that. So we're plugging in 25,000 minus y wherever we see the letter x, and then now we have one equation and one unknown. We can go ahead and do the algebra, and I'm just going to quickly go through these to show you what our value ends up being. And this one we end up getting y being 7,000. Once you get y being 7,000, plug it into equation number 1 over here on the left, and you get x equals 18,000. Similar problem is a chemistry lab problem. If you have two acid solutions, one's 20%, the other's 35%, how much 20% acid solution and 35% acid solution should be used to prepare 25 liters of a 26% acid solution? Well, let's define our variables. X is the amount, the number of liters. What I mean by amount is the number of liters of 20% acid, and Y is the amount of 35% acid. So we want to find out how many liters of each of those acids do we need. And so we can write two equations and two unknowns. And I went the wrong way again. So 0.2 times the amount of 20% plus 0.35 times the amount of 35% is going to equal 0.26. That's our 26% solution. The second one is x plus y equals 25. And I think I have a little error in here. I think I need to make that 0.26 times 25, right? Because that's how much we have. So let's go ahead and solve these. I have this one solved for x, and I'm going to plug that back into the other equation. So plugging that in right over here, let's go ahead and do this. Wherever you see the letter x, replace that. And then now it's just a matter of simplifying. 0.2 times 25 gives us 5 minus 0.2y, and then working that through, we end up getting y equals 10. Well, if y equals 10, then we have to solve for x, and x works out to be 15. So we have 15 liters of 20% acid and 10 liters of 35% acid. Not sure where I put that one. Not seeing it on here. So we'll go ahead and write that one in. How much solution, what percent of each solution did we have? And I'll go ahead and write x equals 25 minus 10. So x equals 15 liters. All right, this is our last problem for your notes. How many rotations does a 15-inch radius tire make per second on a sport utility vehicle if it's traveling at 70 miles per hour? So this is kind of a fun problem. It's basically just doing an analysis of changing your units. So we're going to start with our 70 miles per hour. So we go 70 miles in 1 hour, and we want to convert that to seconds. Okay, so we need a conversion from hours to minutes. And 1 hour is 60 minutes, and then 1 minute is 60 seconds. So this will give us our miles per second. Now we need to figure out a conversion from miles into, so it says how many rotations does a 15-inch radius tire make per second on a sport. So we need rotations per second. So let's go ahead and change our miles into inches so that we can deal with the circumference in just a second. So there's 1 mile is 5,280 feet. And I'm not sure if I've explained this to you before or not, but you always want to line up your units so that they will cancel. So in other words, hours cancels right here with hours, minutes with minutes, seconds are what I'm left with. This one I've got miles here and miles here. So right now my units, if I were to just calculate this, would be feet per second. So let's go ahead and continue working this one through. So then we need a conversion from feet to inches, and 1 foot is 12 inches. So now we have feet are canceled here, and our units are inches per second. Well, we don't want inches per second, we want rotations per second. So the last thing we need to calculate is how many rotations, how far does it go in one rotation? Well, that has to do with the circumference. of the tire, and circumference is found by using the formula 2 pi r, and so that's 30 pi in one rotation. So let's plug that in. So one rotation is 30 pi inches, and then you can see our last unit here cancels, and we have inches that cancel. So now we have rotations per second are what we're left with. And so if anything on the top gets multiplied, so you're going to take 70 times 5,280 times 12, and then divide that by 3,600, and then also divided by 30, and you end up with 13.07 rotations per second. So those are some examples of some word problems using some of the things that we've been talking about in this chapter. So hopefully that will help you with your assignment, and we'll see you next time.